Chapter 1. The Beginnings. Our first conceptions of number and form date back to times as far removed as the Old Stone Age, the Paleolithic era. Throughout the hundreds or more millennia of this period, people lived in caves under conditions differing little from those of animals. Their main energies were directed towards the elementary process of collecting food wherever they could get it. They made weapons for hunting and fishing, developed a language to communicate with each other, and in the later Paleolithic ages enriched their lives with creative art forms, statuettes, and paintings. The paintings in caves of France and Spain, perhaps from about 15,000 years ago, may have had some ritual significance. They certainly reveal a remarkable understanding of form. Little progress was made in understanding numerical values and space relations until the transition occurred from merely gathering food to actually producing it, from hunting and fishing to agriculture. With this fundamental change, a revolution in which the passive attitude of people toward nature turned into an active one, we entered the new Stone Age, the Neolithic era. This great event in the history of humankind occurred perhaps 10,000 years ago. Wang, when the ice sheet which covered Europe and Asia began to melt and made room for forests and deserts. Nomadic wandering in search of food came slowly to an end. Fishermen and hunters were in large part replaced by primitive farmers. Such farmers, remaining in one place as long as the soil stayed fertile, began to build more permanent dwellings. Villages emerged as protection against the climate and against predatory enemies. Many such Neolithic settlements have been excavated. The remains show how gradually elementary crafts, such as pottery, carpentry, and weaving developed. There were granaries, so that the inhabitants were able to provide against winter and hard times by establishing a surplus. Bread was baked, beer was brewed, and in late Neolithic times, copper and bronze were smelted and prepared. Inventions were made, notably of the potter's wheel and the wagon wheel. Boats and shelters were improved. All these remarkable innovations occurred only within local areas and did not always spread to other localities. For example, the American Indian did not learn of the existence of the wagon wheel until the coming of white people. Nevertheless, as compared with Paleolithic times, the tempo of technical improvement was enormously accelerated. Between the villages, a considerable trade existed, which expanded so much that connections can be traced between places hundreds of miles apart. The discovery of the arts of smelting and manufacturing, first copper, then bronze tools and weapons, strongly stimulated this commercial activity. This again promoted the further formation of languages. The words of these languages expressed very concrete things and very few abstractions. But there was already some room for simple numerical terms, and for some form relations. Many Australian, American, and African tribes were in this stage at the period of their first contact with white people. Some tribes are still living in these conditions so that it is possible to study their habits and forms of expression. Numerical terms, expressing some of the most abstract ideas which the human mind is capable of forming, as Adam Smith has said, came only slowly into use. Their first occurrence was qualitative rather than quantitative, making a distinction only between one or better a, such as a man rather than one man, and two and many. The ancient qualitative origin of numerical conceptions can still be detected in the special dual terms existing in certain languages, such as Greek or Celtic. When the number concept was extended, higher numbers were first formed by addition. For example, 3 by adding 2 and 1, 4 by adding 2 and 2, and 5 by adding 2 and 3. Here is an example from some Australian tribes. Murray River, 1 is Inia, 2 is Pechicheval, 3 is Pecheval Inia, 4 is Pecheval. Kamilaroi, 1 is Mal, 2 is Bulan, 3 is Guliba, 4 is Bulan, 5 is Bula Guliba, 6 is Guliba. The development of the crafts and of commerce stimulated this crystallization of the number concept. Numbers were arranged and bundled into larger units, usually by the use of the fingers of the hand or of both hands, a natural procedure in trading. This led to numeration first with 5, later with 10 as a base, completed by addition, and sometimes by subtraction. So 12 was conceived as 10 plus 2, or 9 as 10 minus 1. Sometimes 20. The number of fingers and toes was selected as a base. Of 307 number systems of primitive American peoples investigated by W.A.C. Eels, 146 were decimal, 106 quinary and quinary decimal, and vigesimal and quinary vigesimal. The vigesimal system, in its most characteristic form, occurred among the Mayas of Mexico and the Celts in Europe. Numerical records were kept by means of bundling. Strokes on a stick, knots on a string, pebbles or shells arranged in heaps of fives. These are very much like those of the old-time innkeeper with his tally stick. From this method to the introduction of special symbols for 5 to around 10, 20, and so on was only a step. We find exactly such symbols in use at the beginning of written history, at the so-called dawn of civilization. The oldest example of the use of a tally stick dates back to Paleolithic times and was found in 1937 in Vestanus, Moravia. It is the radius of a young wolf, 7 inches long, engraved with 55 deeply incised notches. The first 25 are arranged in groups of 5. They are followed by a simple notch twice as long which terminates the series. Then, starting from the next notch, also twice as long, a new series runs up to 30. It is therefore clear that the old saying found in Jacob Grimm, and often repeated, that counting started as finger counting, is incorrect. Counting by fingers, that is, counting by 5s and 10s, came only at a certain stage of social development. Once it was reached, numbers could be expressed with reference to a base, with the aid of which large numbers could be formed. Thus originated a primitive type of arithmetic. 14 was expressed as 10 plus 4, sometimes as 15 minus 1. Multiplication began where 20 was expressed, not as 10 plus 10, but as 2 times 10. Such dyadic operations were used for millennia as a kind of middle road between addition and multiplication, notably in Egypt and in the pre-Aryan civilization of Mohenjo-Daro on the Indus. Divisions began where 10 was expressed as half of a body, though conscious formation of fractions remained extremely rare among North American tribes. For instance, only a few instances of such formations are known, and this is in almost all cases only of 1/2, although sometimes also of 1/3 or 1/4. A curious phenomenon was the love of very large numbers, a love perhaps stimulated by the all-too-human desire to exaggerate the extent of herds or of enemies slain. Remnants of this tendency appear in the Bible and in other sacred writings. It also became necessary to measure the length and contents of objects. The standards were rough and often taken from parts of the human body, and in this way, units originated like fingers, feet, or hands. Names like ell, fathom, and cubit also remind us of this custom. When houses were built, as among the agricultural Indians or the pole house dwellers of Central Europe, rules were laid down for building along straight lines and at right angles. The word straight is related to stretch, indicating operations with a rope. The word line is related to linen, showing the connection between the craft of weaving and the beginnings of geometry. This was one way in which interest in measurement evolved. Neolithic people also developed a keen feeling for geometrical patterns. The baking and coloring of pottery, the plating of rushes, the weaving of baskets and textiles, and later the working of metals led to the cultivation of plane and spatial relationships. Dance patterns must also have played a role. Neolithic ornamentation reveled in the revelation of congruence, symmetry, and similarity. Numerical relationships might enter into these figures, as in certain prehistoric patterns, which represent triangular numbers. Others display sacred numbers. Here are some interesting geometrical patterns occurring in pottery. Weaving, or basketry. These can be found on Neolithic pottery in Bosnia and on objects of art in the Mesopotamian Ur period. Patterns of this kind have remained popular throughout historical times. Beautiful examples can be found on dipylon vases of the Minoan and early Greek periods, in the later Byzantine and Arabian mosaics, and on Persian and Chinese tapestry. Originally there may have been a religious or magic meaning to the early patterns, but their aesthetic appeal gradually became dominant. In the religion of the Stone Age, we can discern a primitive attempt to contend with the forces of nature. Religious ceremonies were deeply permeated with magic. and this magical element was incorporated into existing conceptions of number and form, as well as in sculpture, music, and drawing. There were magical numbers, such as 3, 4, and 7, and magical figures such as the pentolfa and the swastika. Some authors have even considered this aspect of mathematics the determining factor in its growth. Though the social roots of mathematics may have become obscured in modern times, they are fairly obvious during the early section of human history. Modern numerology is a leftover from magical rites dating back to Neolithic, and perhaps even to Paleolithic, times. Even among very primitive tribes we find some reckoning of time. Consequently, some knowledge of the motion of the sun, moon, and stars. This knowledge attained its first more scientific character when farming and trade expanded. The use of a lunar calendar goes very far back into the history of humankind, the changing aspects of vegetation being connected with the changes of the moon. Primitive people also pay attention to the solstices, or the rising of the Pleiades at dawn. The earliest civilized people attributed a knowledge of astronomy to their most remote, prehistoric periods. Other primitive peoples used the constellations as guides in navigation. From this astronomy resulted some knowledge of the properties of the sphere, of angular directions, and of circles. These few illustrations of the beginnings of mathematics show that the historical growth of a science does not necessarily pass through the stages in which we now develop it in our instruction. Some of the oldest geometrical forms known to humanity, such as knots and patterns, only received full scientific attention in recent years. On the other hand, some of our more elementary branches of mathematics, such as graphical representation or elementary statistics, date back to comparatively modern times. As A. Spicer has remarked with some asperity, already the pronounced tendency toward tediousness, which seems to be inherent in elementary mathematics, might plead for its late origin, since the creative mathematician would prefer to pay his attention to the interesting and beautiful problems.